Hi class, in today's lecture we're going to be talking about monopolistic competition and oligopoly, and this is chapter 11 in your textbook. So let's review our market continuum. So we already talked about perfect competition on the left. If you remember, that was the most competitive environment possible. Each firm had zero market power. And we talked about a monopoly on the far right, which is the other extreme, which is the least competitive environment, and is one market structure where there's full market power. Today we're going to be talking about imperfect competition, which just means these two in the center here, monopolistic competition and oligopoly. Imperfect competition is in a nutshell, is a market structure in which producers are identifiable and have some control over their price. Monopolistic competition is similar to perfect competition. The big difference here is that we're going to make the assumption that the firms can differentiate their product to a certain extent, and then this differentiation will give them some control over their price. An oligopoly is a market structure in which there's very few firms, maybe potentially 4 firms, that are dominating the industry, and so the market share is dominated by a few large firms. So imperfect competition is competition between firms based on some factor other than the price. One example of this type of competition is product differentiation. And so product differentiation, just to elaborate, is any attempt to distinguish a firm's product from those of its competitors. Now, this doesn't necessarily mean the product itself. You could have a business, say a dry cleaning business, and they could be otherwise similar, but one could have a different location than the other. And the location will, allow one of the firms to charge a higher or lower price, depending on how convenient their location. So in terms of product differentiating, we're speaking very generally. And so, it would include things like location or the service, and of course the products themselves. But when we're talking about product differentiation, we're just being very general in what we consider different. And so advertising plays an important role in any market structure where the firms can differentiate their product, because they need to get this information out to the consumers. They'd like to stress what their differences are. And so this leads us to a little bit of a sidebar on advertising. If you remember at the beginning of the course, we talked about an economic system and we talked about efficiency, and an economic system takes our scarce resources and makes goods and services that satisfy our wants and needs. So the question becomes here is advertising an efficient use of our scarce resources? Well, some of the benefits of advertising are that it provides consumers with vital information. We get to know about what products. After all, we do like to buy goods and services. They satisfy our wants and needs, and so we'd like to know where to get things that can do that. And so advertising helps us reduce our search time. If it wasn't for advertisement, we'd have to physically go to, or first physically, find where firms are located that will be selling what we want, and then we'd have to physically go to that location to be able to see what they offer for sale. It could potentially enhance competition between firms. So a firm that is about to enter an industry, they can use advertising to speed up the process of gaining market share. It could potentially lower the price of products if it leads to a larger market share, which could lead to economies of scale. And finally, advertising finances a lot of content that we watch. So, for example, television programs are for the most part funded through advertising, and a lot of the content that we view on the internet is sponsored by advertising. So if it wasn't for advertising, much of this content would not be available. It could be available, but it would have to be through some kind of a subscription service, and so we would have to pay subscription for any content, say on the internet, that we use. So in that sense, advertising is very important because it fosters a lot of content that we find useful, especially on the internet. Of course, there is many criticisms of advertisements. I remember looking at some studies on advertising on their effectiveness, and it tends to not be all that great. However, it's very hard to measure the effect of advertising because there's there's the short-term effect. If you run some ads, does that boost your sales? But at the same time, there's long-term effects, but you're just getting your name out there. It could be 6 months down the road that a consumer is in need of some product, and then they remember the advertisement, for example. And it's very hard to measure the value of building brand awareness and things like that. So some could argue that overall it might not be all that informative and could be very wasteful. So it's a waste of our scarce resources. So in that case, it would be inefficient. And some would argue too that it, ends up encouraging more concentration within an industry. Through the use of advertising, you could get, a sort of strongest survive type of a situation, and you end up with only a handful of firms, and so they have a lot of market share. And if you think of our marginal cost curve, well, advertising is obviously going to shift that marginal cost curve up. And so our simple model that we learned would predict that the quantity and price would be higher as a result of advertising. So let's talk about industry concentration. So we're looking at two market structures here: monopolistic competition, which has a lot of firms, and oligopolies, which just have are very concentrated with only a small number of firms dominating the industry. And so to be able to distinguish the two, we could use different measures. We're going to look at two of them: the 4-firm concentration ratio and the Herfindahl index. The Herfindahl index is not in your textbook, but it's very simple, so I'd like you to make sure you know it for the final exam. Just cover what's in the lecture slides here. So the 4-firm concentration ratio, it's very simple. All it is it's a ratio, and in the numerator you have the sales of the 4 largest firms, and then you just divide it by the total sales in the industry. And so you're looking at the how much of the total industry is represented by the 4 largest firms, or the proportion of the total industry that the 4 largest firms represent. So there's a rough rule of thumb. If we calculate this ratio and it's less than 40%, then we have some evidence that it's, it would probably better fit into the monopolistic competition category rather than the oligopoly category. If it's greater than 40%, then it's more along the lines of an oligopoly. This isn't a hard science, it's just a rule of thumb. In Canada, for example, we have a lot of highly concentrated industries. Here's a list here on the left, and you can see that in 1990, the 4-firm concentration ratio was quite high for many of these, with the exception of sugar and confectionery and wineries, and sporting and athletic goods was quite low. But many of these industries are very concentrated, and you can see that since the 1990s, they've actually become much more concentrated. Now, the Herfindahl index is simply the sum of squared market share. So what you do is you take the market share for each firm in the industry, and for each of the firms, you take that market share and you square it, and then you sum all of those squares. And so if you use whole percentages here, so you've multiplied them by 100, right? Then it will range between 0 and 10,000 points. So for example, an index of 0.25 would be 2,500 points. It depends on, you could put the the proportion in here. So instead of 80%, you would put 0.80. If you do that, it'll range between 0 and 100. So there's again some rules of thumb here we can follow. There's a rough guideline. So basically, if you're below 0.15 or 1,500, depending on if you use the whole percentages or not, these are relatively unconcentrated. So obviously a very small number would be a very competitive industry. But for values above, say, 2,500, that would be, evidence for an oligopoly. So let's look at an example here. So we have two different measures. Why do we have two different measures? Is there a difference between the two? Is one better than the other? Well, it's easy to see that for the four-firm concentration ratio, we could have two different cases, and in either case, what it says about the industry is quite different, but you would end up getting the same value for the four-firm concentration ratio. So in this example, we're going to suppose that the four largest firms have 90% of the sales in the industry. Okay, so we're basically saying then that the four-firm concentration ratio is 90%. Okay, and then for the remaining 10%, we're just going to assume that it's divided among 10 equally sized producers. So case one, the four largest firms each have 22.5% of the market. Okay, so if that's true, then we'll get a concentration ratio of 80%, a four-firm concentration ratio of 80%. But we can also suppose that the largest firm has 80% of the market, and then the next three of the four each have 3.3%. And so again, your four-firm concentration ratio will be 90%. So let's compare let's compare this four-firm concentration ratio to the High-Findle index. So again, in both of those cases, the four-firm concentration ratio is 90%. And again, that's what we said. By what we defined in terms of our example, we said that they're 90% of their, those four largest firms represent 90% of the sales in the industry. But remember the two cases. So both cases give you the same number for the four-firm concentration ratio, but case one would suggest much more competition because there's four firms of equal size, compared to the second case, which you pretty much have one firm with 80% of the market share, and so it's pretty much a monopoly. And so the four-firm concentration ratio isn't picking up that distinction, but the Herfindahl index will. And so if we calculate the Herfindahl index for each of the two cases, we get a much different number. In case one, we're going to square the market shares of each of the firms, and so we know that the four largest firms are all the same size, and so we're just going to take 4 and multiply that by 0.225 squared. And then we have our 10 remaining firms, which represent 1% each of the market share. So we square that and then just multiply that by 10. And so we get 3,025. Now in the second case, we take the market share of the largest firm, which has 80% market share, and square that. Then we're going to add the other three. Each of those are equally the same, they're all the same size, and they're each 3.3%. So we're going to square 3.3%, or 0.033, multiply that by 3, and then we're going to add, we have to account for those other 10 firms that are each 1%. So we put that term in here. And if we do that, we end up getting 7,433.3. Okay. Now, just to mention, I think when I calculated these, I used 80 instead of 0.8. But I think you get the point. The bottom line is, the Herfindahl index will pick up this very large firm. And the reason for that is that we're squaring the market shares prior to them being summed. So this will give additional weight to firms with a larger size. Okay, so here's an active learning question. So you might want to hit pause and see if you could figure it out on your own, and then I'll show you the answer. Okay, so to get the four-firm concentration ratio here, we're going to take the sales of the four largest firms. So that's going to be F, D, C, and A. Okay, F, D, C, and A. And so we're going to take that. That sums to 66, but then we're going to sum this entire column, and we get 92. So we just take 66 divided by 92, we get 71.7%. And so this seems to be more of an oligopoly rather than a rather than a monopolistically competitive industry. And remember, our rule of thumb is roughly 40%, and so we had 71.7%. Now, how would you go about calculating the Herfindahl index? Okay, so I'll maybe hit pause, try and calculate it yourself, and I'll show you the answer in a sec. Okay, so what we're going to do is square each of these market shares. Okay, so we can, take 0.22 squared, add 0.6 squared, etc. But for these last four, we're going to assume they're of equal size. And so their market share, or their sales then, each would be 3 million, because 3 times 4 would give you 12 million. And so then each of their market share would be, for each of them would be 4 divided by 92. Okay, and then once we have those, we square them and then just take the sum. Okay, and so here's the solution. So the market share for these last four are 3.3 each. That's just obtained by taking the 3 and dividing it by the 92. So these are our market shares. We're just going to square them. That's what this column does. And then we take the sum. And so we get that the Herfindahl index is 1509.9. So deciding whether a particular industry is an example of monopolistic competition or an oligopoly is not an exact science. Again, we have these measures that we just looked at, but they're rough rules of thumb. Again, this is just a summary. The rule of thumb for the concentration ratio is, the threshold is roughly around 40%, and the threshold for the Herfindahl index is roughly 0.25. What we really want to know here is, would the total supply of this industry be seriously affected or not by the exit of its largest firm? And so if we can answer yes to that, then it's clearly an oligopoly industry. If it's not, then we're talking about a monopolistically competitive industry. So recall the characteristics of monopolistic competition. So we did, I think, mention these earlier, but let's just, look at them again. So similar to perfect competition, there's many sellers. Each firm is just operating on their own. They're very small relative to the entire market. But the key difference is that we're going to assume that they can differentiate their product slightly from their competitors. And so because of this, rather than just taking the prices given like in perfect competition, they can, adjust their price a bit. Basically, we're saying they're going to face a downward sloping demand curve. So they could increase their price and not lose all of their sales like in perfect competition, because some people might be interested in their product that, is slightly different than the competitors. We'll see that the assumptions in this market structure would yield a demand curve that is fairly elastic or flat. We're also going to assume that there's free entry and exits of firms. And so in the long run, again, we would expect that economic profits would be driven to zero. And so each firm has some control over their price because of this differentiation. If you think of the hamburger industry, like McDonald's, Harvey's, etc., they can set their, they have some freedom to set their own prices. If McDonald's increases their price of a hamburger more than another restaurant, then there are reasons for people to still buy because of their hamburgers being differentiated. So they have some control over the market price. But of course they can't, they can't triple their price. They won't get any sales, right? But for the most part, you can think of maybe around the average price or something like that. They have some leeway to change their price. And so they have some market power in that sense. So if you remember in our elasticity chapter, I gave you a phrase here, and it said, can consumers easily substitute or do without? And so if we can answer yes, then we're talking about elastic demand, right? So in the case of a monopolistic competition, there's a lot of different firms by assumption, and they're selling a slightly differentiated product. And so consumers have lots of substitutes available. So for any particular, say, hamburger restaurant, a consumer can easily do without, and they can substitute, right? It depends. So they can easily do without. I would more focus on the substitutability part, because you could easily do without any kind of hamburger, right? but it's the substitution that's key here. There's lots of substitutes, and so that would constitute an elastic demand curve. Okay, so it's not perfectly elastic like in perfect competition because of this differentiation. So in the short run, again, we're using the same cost structures here. So one thing to point out here is the monopolistically competitive firm is facing a downward sloping demand curve. So all of the technical stuff related to profit maximization is all the same. We set marginal revenue equals to marginal cost. That would determine the profit maximizing quantity. To be able to sell that quantity, the firm could charge at most a price P1. In this example, P1 is greater than the average cost at that quantity, and so we have an economic profit indicated by the area of this rectangle here. And so in the short run, if firms are making economic profits, our assumption is that because of free entry and exit, that would attract firms into the industry. So if we think about the long run, so actually I'll go back to that slide. So if new firms are attracted to the industry, that means that the demand curve here is going to shift to the left and become more flat. If you just think about it, if there's more firms attracted, that means there's more substitutes. And there's going to be less quantity demanded for this particular firm, for example, at any price. So the demand curve is going to shift to the left, and because of the greater amount of substitutes available, it will flatten out. And that will occur until we get zero economic profit. So you can think of this demand curve and marginal revenue curve as shifting to the left and flattening out until it gets to a point where the profit maximizing quantity will yield a price equal to the average cost, like in this diagram here. So here, the profit maximizing quantity occurs where it occurs where the price that they would need to charge to make, to be able to sell that quantity is also equal to the average cost, not the minimum average cost, but the average cost curve. And so here we have zero economic profits. And this is just another illustration here. So again, we set marginal revenue equal to marginal cost. We go up to the demand curve and over to get the price. In this case, the price is the same as the average total cost or average cost, and so they're earning a zero economic profit. So let's think about efficiency here. So remember, productive efficiency occurs when the firm is producing at the lowest average total cost. Okay, and so this occurs when the price equals the minimum average cost. You remember from perfect competition. And so we're going to think about whether or not this, a firm in a monopolistic competitive industry achieves this. Well, we kind of already saw that they didn't, right? They would typically produce a quantity less than the optimum quantity, the socially optimum quantity or efficient quantity, and you would get that the price is equal to average total cost in the long run, but not the minimum average total cost. Okay, so that's because of we have that demand curve shifting because of new firms entering. Now, allocative efficiency. So in order to have allocative efficiency, the equilibrium quantity, at the equilibrium quantity, you need the price equal to marginal cost. But we know we have a downward sloping demand curve. And so as we talked about in the last chapter for a monopoly, the price is not going to equal marginal revenue. And so at the optimum, marginal revenue is not going to equal the price and equal the marginal cost. So if you remember, when we're talking about allocative efficiency, we want to maximize total surplus, right? And so in that case, you need to have that the price is going to be equal to the marginal cost. Here, the supply curve would be the marginal cost. And so that's not going to happen in a monopolistically competitive industry. For similar reasons why it didn't happen for a monopolist. The key difference, though, with monopolistic competition is that the demand curve, we assume, is much more elastic. Typically in a monopoly, because there's no other substitutes, it's the demand is relatively more inelastic. And so a firm in a monopolistically competitive industry will produce at a quantity below the optimum and not at their minimum average total cost. So since they're not at their minimum average total cost, there's still some room for cost improvements, and so we call that excess capacity. Okay. So what's good about monopolistic competition is that it produces a lower output. That's not what's good, but that's, they tend to produce a lower output than a perfectly competitive firm. It doesn't achieve productive efficiency or allocative efficiency. Okay. And I'll just go back to that slide. But again, we just talked about how the price doesn't equal the minimum average total cost. And we would have that price is greater than marginal cost. Remember, when you have a downward sloping demand curve, the marginal revenue doesn't equal the price, right? The marginal revenue will be less than the price. And so at the, you're going to end up with, if marginal revenue is equal to marginal cost, then that the price will be greater than the marginal revenue. And so price will be greater than marginal cost. So just some qualifications. There could be persistent profits if we're thinking about the long run. If, for example, they continually differentiate their product and continually try to distinguish it and make it something that the firm would want compared to the other firms. And it's possible that entry could be somewhat limited by the financial investment required to establish product differentiation. In other words, the amount of advertising required. So the barriers, there might be a somewhat of a barrier of entry here, not as strong as we'll see for oligopolies, but there could be some significant expenses that new firms would have to endure in terms of advertisement. But still, overall, we're going to get the same efficiency results. But one of the advantages of this market structure is product variety. So, it's just, we may not make those efficiency measures, but we are able to get some product differentiation, which is good. And, remember our discussion on diminishing marginal utility. Clearly, after that discussion of utility and how it diminishes after we're consuming the same good, product variety could increase our overall utility, right? So that's the main idea. So just in terms of a summary, for profit maximization and monopolistic competition, as always, we set marginal revenue equal to marginal cost. You want to keep doing something as long as marginal revenue, which is your benefit, exceeds the cost. In the short run, you could have profits or losses, and so the entry and exit of firms, depending on which of those two cases are true, will lead to a zero economic profit in the long run. And again, this is the consequence of the free entry and exit of firms. And again, the efficiency measures, allocative efficiency and productive efficiencies, are not met as they were in perfect competition. So we would expect firms to produce a lower quantity and charge a higher price. And the price won't be equal to marginal cost or the minimum average total cost. Okay, so let's switch over to oligopoly now. So there are 5 characteristics of an oligopoly. It's dominated by a few large firms. Entry by new firms is difficult. It's not impossible like in a monopoly, but it's much more difficult. Non-price competition like advertisement would be widely practiced. We'll talk about why they wouldn't want to compete on price in a moment. Each firm has a significant control over its price. meaning they can change their price and not lose all of their sales. If they increase it, it's not like the perfectly competitive environment. However, there is a mutual interdependence between firms. So let's elaborate on what I mean by this. So if you think of the other market structures, monopoly, for example, the firm is the only firm. It doesn't need to worry about rivals. It's all on its own. In the first two market structures, perfect competition and monopolistic competition, the firms operate in sort of a vacuum. They're very, very small. They have no impact on the overall market. And so they don't really need to worry about what others are doing. But that's much different in the case of an oligopoly. If you only have a few different firms, say you have 4 firms or maybe 2 firms, each of the firms make up a significant portion of the industry. And so if one, say, drops their price, trying to steal away market share, they could be met with retaliation, and the other firms could also lower their price. And so they do have some control over it. They could control their price, but they need to worry about what their rivals will do. And so in that sense, they're sort of constrained. So just in terms of some examples of oligopolies in Canada, there's a lot of them. These are just 3 different examples. Our airline industry is highly concentrated. WestJet and Air Canada essentially take up 80% of the market. The banking industry, we do have a lot of banks. So there's many smaller banks, but there are 5 dominant banks which make up the majority of the market share. For example, TD, Royal Bank, CIBC, etc. And we all probably are familiar with this. Rogers, Bell, and Telus are the only 3 wireless carriers, and they have about 90% of the market. And I believe Freedom Mobile might be the other smaller one. But, the market is dominated by 3 firms. So in an oligopoly, each firm is large and powerful and, can set the price of its own product. But as I mentioned before, any pricing decision that they make could generate a response from a rival firm. So the power of, say, firm A is very much constrained by the anticipated reaction of a competitor, say firm B. And it's because of this mutual interdependence. And this plays a crucial role in the oligopoly environment. So this mutual interdependence, creates uncertainty about how their rivals will react to any changes in their output or price. And as a result, because of it's very complex to model this, there's no sort of single oligopoly theory of price and output like we have for the other 3 market structures. So we can't say the price will be higher and the quantity will be lower. And in fact, we're not going to be able to have a profit maximizing analysis like we did with the other market structures, because it requires much higher level mathematics. So you would learn that in an intermediate microeconomics course. But essentially, just because of this complexity in terms of modeling their behavior, we would need a much more involved analytical framework. And actually what we would use would be called game theory. So in economic theory, oligopolies are modeled with game theory models. We're going to get a little taste of that today, but we're not going to get into the details. So you would essentially have to set up like a reaction function for each firm, and then in the reaction function, you would have what your rivals might do as a reaction to what you do, and then you have a system of equations, and you would solve it for the optimum strategy. So we won't be doing that here, but we will get a little taste of game theory. Another issue with oligopolies is collusion. So it is illegal in Canada to collude, so firms aren't allowed to do this. The Competition Bureau monitors this sorts of things. They would administer fines and that sort of thing. But still, there is always this temptation. So, the world of an oligopoly is sort of this struggle between cooperating and competing. Now, you can think about why it would pay for them to cooperate. So, basically, if there's only two firms, suppose there's just two firms, well, they could, in principle, get much higher profit if they behaved like a monopolist. So they basically would want to get together and, figure out what the optimum quantity would be to produce, and then they each would produce that. There would be this, optimum quantity overall, and then they would split that and charge the price to be able, that coincides with that quantity. So they each would, produce half of the monopoly, quantity, and they would both charge the same price corresponding to that quantity, and that would maximize their profits. That would be the best thing they can do. So there's, so they would need to get together and make an agreement to do that. And so that's what collusion is called. And basically it's an agreement for suppliers to set the price of the products or quantities each will produce. And I mean, the prices and quantities are related. So if they would want to figure out what the monopoly output would be, and then charge the price according to that. And then they each would charge that price. We're going to go over a simple example or illustration here, a little bit of a story. This is from the textbook, to illustrate the concepts that I just talked about. So we're going to imagine a small isolated village. It possesses an abundant supply of drinking water from the well. So there's a well with drinking water. Now villagers used to have free access, but for whatever reason, Aman is granted ownership of the well. So basically he has a monopoly on water, and his cost structure is here. We're just going to keep things simple and assume, because it's water, that the marginal cost is equal to 0. And so in the village, this is the demand for water. So that's just the demand curve. This is what everyone would want to buy at different prices. Here we're going to call our money shekels. Now, of course, we know that if we have a linear demand curve, the marginal revenue curve falls twice as fast. It's going to the marginal revenue is going to intersect the horizontal axis at the middle of the demand curve. Okay, and so Aman, if he wants to maximize his profit in this case, it would actually be the same thing as maximizing his revenue, because the marginal costs are 0. And so we know from our elasticity chapter that occurs at the center of the demand curve. Remember, we had a graph with the demand curve, and then we had like a parabola shape underneath, which was the total revenue, and it maximized at the center of the demand curve. So in this case, because the marginal costs are 0, Aman would want to charge 5 shekels per unit of water. Okay, and that would maximize his revenue, and in this case also his profit, only because we're assuming marginal costs are equal to 0. Okay, so we have Aman. He's going to want to charge $5 for a jug of water, and that will maximize his revenue, and in doing so he'll be able to earn a total revenue and profit in this case of 250 shekels. 5 times 50. Okay, now suppose there's another person, Omar, and he discovers another bountiful source of fresh water. And he knows that Aman's charging 5, so he's going to come in and charge $4 shekels for a unit of water. Now, what will the result be? Well, the result would be that everyone starts buying from Omar. And that's understandably, their water's water, he's selling it cheaper. So Aman would be not too happy about this, and let's suppose he drops his price to 2 shekels. And then Omar after that retaliates and drops his price even lower at 1.5 shekels. So basically what's going on here is you have a price war, and both are going to lose as a result of this price war. And also, the price can go quite low because the marginal costs are 0. So we can even think of the price going to almost 0. Now, of course, both of them are going to realize, this isn't an optimal situation. This is terrible. So they're going to realize, well, they could probably collude. So their best bet is to work together. So what they would want to do is produce the, monopoly maximize, the monopoly, quantity that would maximize profit. So that was 50 jugs, if you remember, and then a price of 5. So the best option for both of them would be to collude, behave as a monopolist. So they would, in total, want to produce 50 jugs of water, and then split that up. So each will produce 25, and then they both charge a price of $5. Now, this is better than the price war, but for Amon, it's worse off because before he was getting, a total profit of $250. Now he's only going to get $125 because he's selling 25 jugs at $5 per jug. But another issue with collusion, which happens a lot, is that there's an incentive to cheat. So they have this agreement, but, for example, Amon might get a little upset that he's not making what he had before when he had a monopoly. And so he might say, you know what, I'm going to just produce, instead of 25, I'm going to make 10. And if that's the case, so if he increases his output to 60 jugs, the price in order to sell all of those would have to be four shekels according to the demand curve. So in this case, he would make out better. So Amon would get an increase in revenue, since 35 jugs at 4 shekels is better than his 25 at 5. Okay, so he's making a little extra money. Omer, on the other hand, would lose because now he's going to be selling 25 jugs at $4. But, Omar is going to be obviously thinking the same thing, and he would also conclude that an increase in output to 35 jugs would also be in his best interest. But that's going to, in order to sell all of those, the price would need to fall. So you end up almost in a situation again where they're both going to be, this tit for tat situation, and both of them are going to end up with lower revenues. So we could model this behavior in game theory and, see what probably the likely outcome would be. So this is called a payoff matrix. So all we have here are the choices for each person. So we have Amon on the top, Omar on the left here, and each of them can either, maintain the agreement, don't cheat, or cheat. Okay, Omar can cheat or don't cheat. If they both don't cheat and stick to the agreement, they will both get a payoff of 125. Okay, but if, say, Amon cheats but Omar doesn't, Amon will make out well. So Amon's payoff is in the red triangle here, so that would be 140, and Omar's payoff is 100. Okay, so if Amon cheats and Omar doesn't, you'll end up here, and I have these listed here. So cell C then would just be the other way around. This is when Omar cheats and Amon doesn't. And then cell D is if they both cheat. And if they both cheat, they will get 105. So let's think about what would, there's a way we could sort of find an equilibrium here. And also note that this game is symmetric. So, we have 140 and 140 here, 100, 100 here. You can see that the game is totally symmetric. So a Nash equilibrium is what we're trying to find. And a Nash equilibrium is a situation where each rival chooses the best actions given the anticipated actions of the other players. So how do we figure out what each, person's strategy would be? What's their best strategy? So in order to do that, let's first look at Amon. Okay, so we're gonna look at Omar's choices. So Omar can either cheat or don't cheat. And so what we're going to do is look at Oman and look at, his two options for each of what the options of Aman are. So let's suppose that Aman doesn't cheat. Okay, so if Aman does not cheat, then what is Omar's best choice? Well, Omar's best choice would be 140 shekels, right? We're comparing 140 to 125. So if Aman doesn't cheat, the question is, should Omar cheat or not cheat? Well, his best option would be to cheat, because if Aman doesn't cheat, he can get 140 shekels if he cheats. What if Aman cheats? Then we're comparing these two numbers. And so for Omar, if Aman does cheat, then his best option is to also cheat, because then he'll be getting 105. Okay, so that's, so basically Omar has a dominant strategy to just cheat, right? Because whatever the other person does, Aman, he will get the highest payoffs if he always cheats. And since the game is symmetric, it's going to be the same thing for Aman. So Aman now is thinking about whether, the two choices for Omar. So if Omar doesn't cheat, what's Aman's best option? Well, we're comparing 125 to 140. So it's 140. Here we're comparing, if Omar does cheat, what's Aman's best option? Well, is it going to be don't cheat or cheat? Well, it's going to be to cheat. So they both have a dominant strategy of cheating. And so in this case, if you were to think, if I left these boxes I put on, we would end up having two boxes in cell D, and that would indicate the Nash equilibrium. So in this case, if they're thinking rationally and, considering the anticipated actions of the others, so if they go through this thought process, then their best option is both should cheat. And now this is in the face of the fact that they both know that if they don't cheat, if both of them know they don't cheat, they both don't cheat, they'd have the highest payoffs. Okay, so anyways, that's the main idea. That's the Nash equilibrium. It doesn't necessarily mean every person would go to this, but a rational person looking at all of the options would find this to be optimal. And so this Nash equilibrium is named after the Nobel Prize winner economics John Nash. There's actually a movie about him, a Hollywood movie called A Beautiful Mind. So they don't really explain in the movie or here exactly what he did, but so I think the idea of this type of equilibrium already existed. But what he did is he did in mathematics what is called an existence proof, and he proved that a Nash equilibrium of this type exists for finite games, and then even if there's mixed strategies where you could randomize your choices. We won't get into that, but that was his contribution. He basically did an existence proof, and I think it was his PhD thesis actually. So it was actually quite impressive. So anyways, that's a Nash equilibrium in upper year economics courses if you were to take them. Unfortunately, we don't offer them at Sheridan, but anyways, you would learn more about this type of modeling, and you would use a lot of calculus and stuff for this. You would set up a function for each player's like their strategy function, and then that would be a function of the anticipated actions of the rivals, and then you'd have a system of equations, and you want to find where you get a Nash equilibrium, which would be where you have this sort of intersection. So another issue that comes about in terms of a monopoly, an oligopoly, is what's called price leadership. So this is almost as, this would, if you were to observe, say, gas stations or something like that, all of a sudden changing their prices in a similar time period, it would appear as if they're colluding. And that's illegal. But in fact, there could be just sort of an underlying sort of convention that, through trial and error over time, one of the firms tends to become a leader in the industry. So the other firms concede the role of price leader to a single firm. And so maybe this could be something like Esso, if you're thinking of the gas stations, gasoline and industry in Canada. And so no one else changes their price unless this price leader does. And so if the price leader decides to increase the price and that it's profitable, the leader would somehow announce this in a public way, and then the rival firms will quickly follow suit by also increasing their prices. And so it looks like there's overt collusion, but in fact there isn't. They're not, nothing would be illegal here. So that's just, an idea where, we have collusion, but this is like collusion, but it's just, it has the effect of collusion, but it's not actually overt collusion. Now, we're almost done. But before we end, it's important just to speculate about what the demand curve would look like for an oligopoly. So we can think of the oligopoly's demand curve as being kinked here, and you can think about maybe this as being sort of like the average price or something in the industry. Now, or think about it as that, this is you could just think of at any point in time, this would be the price and quantity of a particular firm. Now, what we're going to think about is what happens if they increase their price or lower their price. Well, if they increase their price, their rival firms likely won't match that price increase, because why would they, right? They're seeing you increase your price and they're anticipating then they're going to get more market share. And so in that case, if you increase your price, you're going to lose a lot of sales, because the other firms aren't going to also increase their price, unless you have some kind of a collusive agreement or something like that. But we're assuming that's not the case here. So then your demand curve then will be elastic, right? And if it's elastic, that represents sensitive consumers to the price. And so in this case, we would expect that sales would fall by a lot. So it's elastic. But if this firm lowers its price and tries to steal market share away from its rivals, they're probably going to lower their price too. And so the firm isn't going to be able to get that much more extra sales, right? Because the other firms are lowering their price too. And so then, below P1, the demand curve would be more inelastic. So the firm isn't going to get that much of an increase in sales if it lowers its price. And so you get this sort of kinked demand curve. And then this whole idea here about prices being, taking into account the rivals and that sort of thing, suggests that the prices in an oligopoly market would be very sticky. It's such a sensitive thing to fool around with the price that it's not done all that much in an oligopoly market. So if you were to look at a graph of prices over time, you wouldn't see this continuous, flowing thing, but more of like discrete changes in prices. So the price jumps down or jumps up, and then it stays at the same price for quite a while. That would be different. And if you think of like gasoline prices, and if you think of each gasoline station, a lot of them are independents. It's not as much of an oligopoly in that sense. You see that the prices change a lot. They're very, they change daily, right? Don't seem to be as sticky. Or a better example would be the stock market. When you're thinking of a particular stock, there's people buying and selling them. The price is changing all the time. If you offer more for sale for your stock, you're just a little small player. It kind of behaves more like a perfectly competitive environment. And so when you look at a price of a stock over time, it's, you don't get these big discrete jumps, unless it's a stock that's traded on the like a very thin market. It would be more discrete like that, but for most stocks listed on the exchange, so anyways, the bottom line is prices can tend to be sticky because it's a very sensitive thing, right, when they change their prices. So the bottom line with oligopolies are they tend to be, just in general, again, there's no overall theory like before where we can say they're always going to charge a higher price or a lower quantity, but because of their market power and that they're very large, they would tend to be more, not productive or allocatively efficient. But we don't really prove this. But some things that could help in this regard is, if there was an increase in foreign competition, and then also oligopolies, since they have a large market share, they're profitable, they can afford to invest in research and development and things like that, which could be a positive thing for society. Okay, so I have some multiple choice questions to go through. So the first question here is, which of the following best defines product differentiation? Okay, I suggest you hit pause, try and answer it, and then I'll show you the answer. Okay, the answer here is B. So even things like location and customer service qualifies as product differentiation. Okay, the next question says, in long-run equilibrium, which of the following does the monopolistically competitive firm do? Okay, so hit pause. Okay, so I'm back. Now, if you remember the one slide, when we were looking at the long run, we saw that it would experience excess capacity because it's not at its minimum average total cost. Next question, which of the following is a characteristic of monopolistic competition? Okay, so hit pause. Okay, I'm back. So the answer here is B, a large number of sellers in the industry. The other things listed here are not characteristics of monopolistic competition. We don't have a standardized or homogeneous product. The firms can influence the price a little bit because of their differentiation. And we didn't say there's large barriers to entry in a monopolistically competitive industry. There are in a oligopoly. Okay, so here's a question here where you're going to have to find the Nash equilibrium. So for this, you just want to follow the same procedure that I did in the prior slide. So hit pause and try and figure it out. Okay, so the answer to this question is C. And so to find that, what you want to do is pick one of the firms. So let's pick firm A. So firm A can choose high or low. So we're going to figure out what it would want to do if firm B picked high. So firm B picked high. What would be firm A's best chance or best, payout? Would it be a high price or a low price? Well, in this case, it would be a high price. Okay, so that would be, the best option. So I'll circle that. Okay. Now, if firm B were to pick a low price, what's firm A's best option, high or low? Well, we see that it's a low price again, because 84 is higher than 60. Now let's do this for firm B. So firm B can either pick high or low price. Okay, so if firm A were to pick a high price, what is firm B's best option? Well, we're going to compare 80 with 96, and 96 is higher. Okay, we're going to do the same thing here. Compare 40 and 56. 56 is higher. And so the Nash equilibrium is essentially where you get these, you get two circles here. So both of them would want to choose a low price. That would be the Nash equilibrium. Okay. Next question. Which of the following is similar in both monopolistic competition and monopoly? hit pause. Okay, I'm back. So we're thinking about monopolistic competition and a monopoly. Barriers to entry? Well, no, because there's barriers to entry to a monopoly, but not monopolistic competition. Do they have the same number of producers in the industry? No, of course not. Monopoly only has one. Differentiated products among the industry's producers? Well, a monopoly, you can't have differentiated products. It's just a single product. And so the answer is D, and we know this from the beginning because I mentioned it. Both have a downward sloping demand curve. And so that's why the profit maximization discussion there to figure out what the economic profit or loss is the exact same, because it's a downward sloping demand curve. Okay, so the next question says, which of the following is the goal of any kind of collusion? So don't overthink this one. So hit pause. Okay, so I'm back. So obviously the reason that they would want to collude is to increase their profits. So which of the following describes a Nash equilibrium? Okay, so hit pause and try and figure it out. Okay, so the answer here is B. And this is basically the process that we went through to find the Nash equilibrium. We want to look at what the optimal strategy would be for one of the players given what the other person might do. Okay, so here's your in-class exercise. I think it's best if you do this one for homework. It's fairly straightforward. The solutions are posted on Slate, and you can always bring this up at the beginning of next class if you have any questions. Okay, so take care and have a great day, and we will talk to you next week. Take care. Bye for now.